Question number 14. A probe is used to monitor the quality of the water in the sea. Okay, the probe is suspended by a vertical string which is thrown. Okay, the celestial sphere floats in equilibrium on the surface of the sea. Okay, fine. The sphere has a weight of 5 Newton. So this is the sphere. It has a weight of 5 Newton. The probe and the combined string have a weight of 2 Newton. So whenever there is a force diagram, write the force diagram like this. And the density of the seawater is equal to 1.03 ton cube. Okay, the upthrust acting on the probe and the thread is negligible. What is the volume of the sphere below the surface of the sea? What is the volume of the sphere? Okay, so he is asking you what is this volume? What is this volume inside it? Now how do we do this? Now you see what is the weight here? Total weight is acting like this. Now why isn't the sphere sinking here? Because there is a B over here. Okay, there's a B and there's a buoyancy force acting upwards and this is acting downwards. These two are balancing each other, right? So let us write down the equations. Balancing, that is a buoyancy force B is given by rho liquid multiplied by V multiplied by G, where V is nothing but the volume. I'll write V inside, volume of the object inside the surface of water. This is what it is, and this should be 7 Newton. What I will do is I'll just equate these two. So 7 should be equal to rho liquid V in into G, or what is it I need? I need V in. V in should be equal to 7 divided by rho liquid into G. So let me substitute all this. I'll write it here. So V in is equal to 7 divided by rho liquid. What is rho liquid? 1.03 into 10 to the power of 3 multiplied by 9.8. Okay, now let us do the calculations. I get this as 7 divided by 1.03 is equal to so much divided by 9.8. I made a mistake. 1.03 divided 1.07 divided by 1.03 is equal to so much divided by 9.8 is equal to 0.693. 0.693 into 10 cube or 10 power minus 3. I get this as, do I have, okay, I already have a 6.93. I just mark it blindly because there's no other coefficient here, right? So I can do it directly here.